So in this video what we're going to take a look at is a situation where point-slope form of an equation would make sense. Here we've got Jane. Jane is running a long-distance race at an average speed of 6 miles per hour. Now when she began the race, 1 hour into the race she had completed 8 miles. So in other words, at the beginning of the race she was a little bit more fresh, more energy. She ran a little bit faster than her average speed, but currently her average speed is 6 miles per hour. So currently average speed of 6 miles per hour. But 1 hour into the race, so far she's gone a little more than that. She's gone 8 miles. Now what we want to do is write an equation that tracks her progress in the race, where x is going to represent time and y represents distance. Alright, so let's take a look at the information we've got. Now if I read through it, once again, currently her average speed is 6 miles per hour. She's gotten to a steady pace, and she'll be able to, from this point on, she's going to be able to maintain that 6 miles per hour. So I'm just going to write that over here. So 6 miles per hour. Now we also have a current position on her. 1 hour into the race she has completed 8 miles. So for that first hour of the race she's been able to cover 8 miles of distance. And then we're supposed to put all this into an equation where x represents the time and y represents the distance. Alright, well, whether it looks like it or not, this is a perfect occasion to use point-slope form. Now once again, so you have it in your notes, here's point-slope form. Point-slope form is y minus whatever the y coordinate is equals m, which is the slope, times parentheses x minus whatever the x coordinate is. And we've got all that information here. If you take a look at what we've got, first off, her speed, 6 miles per hour. Or another way to say it is 6 miles every 1 hour. Well, this is slope, because if you remember a couple lessons back, another way to say slope is rate of change. And this is a rate or ratio, 6 miles for every hour. So this is actually slope. So I'm going to label that as m. Now over here, I've got a point of data. It said at 1 hour into the race she had gone 8 miles. So this gives me a current position or a place to start. So I'm just going to put this in parentheses like it was coordinates, where 1 hour is going to be x, or in this case x sub 1. It's our time data. And 8 miles will be y, the distance. We'll call it y sub 1. And so this is why we have point-slope form, so that when we get these situations it's really easy to convert them into an equation where we can now track Jane's progress throughout the race. We have a point of data to start from. We have a slope or rate of change that will help us track her progress after this point, and we can kind of estimate where she'll be at any given point in time during this race. So now to put all this in point-slope form, here's what I do. I take my format, y minus, now y sub 1 is 8 miles. So here I'll put 8 equals m, which is the slope, and we've got that. It's 6 miles per hour, 6 over 1, times parentheses x minus, and then our x sub 1 coordinate, which is the 1 hour. And this would be the equation in point-slope form. Now, depending on what problems you're doing in the book or any problems in general, they may ask you to clean this up, because this is kind of messy. There's a lot going on here, and a lot of people just prefer slope-intercept form. So I'm going to go ahead and go one extra step, and I'm going to clean this up and put it in slope-intercept form. So over here, first off, let's just lose the parentheses. I just put those there to remind myself where to put the 8 miles. So y minus 8 equals 6 over 1 is really just 6, and I've got parentheses here, so I think I'm going to do distributive property, which would give me 6x minus 6 times 1, which is 6. And then for slope-intercept form, of course, we need y by itself, so I'm going to add 8 to both sides. And we get y equals 6x, and then minus 6 and a plus 8 would be 2. Alright, so this is the same equation, just in slope-intercept form instead of point-slope form. It always kind of depends on the problem that you're doing and what they ask for in terms of the final answer. Okay, but this is how we do point-slope form. It's a way for us to take a point of data or a point of information and the rate of change or slope and easily have a format in which we can just stick it straight into an equation that will help us mathematically track, in this case, Jane's progress during the race.